lead code problem group anagrams. So this problem is categorized as a common Amazon coding interview question. So for this problem, you'll be given an array of strings and you need to return a list of all matching anagrams. So essentially it'll be a list of string list. So anagrams are strings where all the characters match but they are arranged in different orders. So for example, eat and tea, both of them have the same characters, they're just rearranged. Yeah, so usually the people who are given this problem, they try to solve it using a brute force, where they compare one string against all the other strings in the list, and they are matched, they keep adding it to a result. So that works, but the time complexity will be very high. Usually for problems like this, the best way to solve it is by sorting them. So imagine if two strings, they have the same characters, but they're in different order. But if you sort all the characters alphabetically, then the two strings will be exactly the same. And we can use that to group anagrams together. So yeah, let's try using it. We'll create a helper method to help us sort strings. And then we'll use a hash map. That'll be a way for us to group all the words which are similar. So yeah, let's try coding that solution. So first thing, let's create the helper method. So private string get sorted string. So it takes in, so the way we can sort a string is essentially by converting it into a character array and calling arrays.sort. So, sorry, character ch. This method just converts it into a character array. Then we call arrays.sort. So arrays.sort is a algorithm which helps to solve it in n log n time. So this is pretty fast. So yeah, now we have a helper method. So for this problem, the result is a list of string lists. So first let's create that. And we just say return result in the end. And then we'll use the hash map to help us. See one error here. So now we are going to traverse down the array list for all words. So first thing we are going to do is get the sorted word. So now that we have the sorted word, we'll just check if it exists in the hash map or not. If it already exists, we'll add it to the array list. If not, we'll create a new array list and add it to the hash map. So if it contains it, we just say hm, we get the array list and add it to it. So hm.get sorted dot add, and we just add the current word. So a lot of people, I think they make the mistake, they add the sorted word, but it should be the current word, since that's the one, it should be there in the result. Else, we create an array list. So list list.add, and then hm.add. So we put so at the end of this, we'll have a hash map where the key will be the sorted word and the value will be all the words which are matching anagrams. So we just add it to the result now. So result.add all. So yeah, let's try running the solution. Oh, so get sorted. Oh, I used the wrong one. All right, all the 3 use cases have passed. So before I submit, I'll just do a recap of the solution. So for this one, the way we are going to solve it is we are going to traverse down the list of strings and just get the sorted string for each of them. And then we are going to add it to a hash map. And at the end, all the anagrams are grouped together and we'll add it in the result and we'll return it. So let's try submitting it. Okay, all the use cases have passed. So yeah, looking at the time and space complexity, so we're beating 97%. So the time complexity, so you have to think of it logically. So imagine n is the size of the array. So we are traversing it once, so it's n, O of n. But then for each of those strings, we are having to sort them before we add it back. So imagine the maximum size of the string is k. And so we're using a sort algorithm, so it's k log k. So it'll be O of n into k log k. That'll be the running time complexity of the solution. And for space complexity, so the only thing we're using is a hash map, you know. So we're using it to keep track of which is the sorted word and the list of available words inside of that. So yeah, so because of that, since we're using a hash map, it'll be O of n.